All right, kiddos, today we are finally going to talk about the unit circle. The unit circle, if you will look right here, what's special about it is that it is a circle with an X and a Y axis. The center of the circle is the origin of the X and Y axis, 0, 0. All right, so what makes the unit circle the unit circle is that the radius from the center to the circle is actually equal to 1. Okay, and then this is going to be a point on the terminal side of your angle theta, and that of course x and y, x and y. Okay, now yesterday's lesson we actually talked about the different values, sine, cosine, and tangent. We discussed that the sine of theta is y over the radius. Now, in the unit circle, you know the radius is always going to be 1. So if you put y over 1, then on the unit circle, the sine of theta is always going to be your y value. Yesterday we talked about the cosine of theta is x over your radius. Well, again, in the unit circle, your radius is equal to 1. So your cosine is x over 1, which is just x. So cosine is always going to be your x value. Now, tangent is not going to change. It's still going to be y over x. And then you can use your reciprocal functions if you need to find the cosecant, the secant, or the cotangent, okay? So when we have a point that's on our unit circle, we call that point P, big P. It's the x and the y, ordered pair. So if x is cosine and y is sine, then that also tells me that any ordered pair that I have x and y is my cosine and my sine. So if I go up here and look at this point on my unit circle, point P is x and y, whatever x is, it is also my cosine of theta. Whatever y is, it is also the sine of theta. So we are actually going to take this information and we're going to look at the unit circle. We're going to focus on values in the first quadrant and then these angles right here, 0 degrees, 90 degrees, 180, 270, and 360. But like I said, we're going to focus on 30 degrees, 45 degrees, and 60 degrees in the first quadrant. And then we'll learn how to find their matching angles in the second, third, and fourth quadrant. Now, when you do degrees in the unit circle, of course you're going to have these that are found on your x and your y axis. So make sure you learn those, okay? It's just 90 every time. 0, 90, 180, 270, 360. That makes one complete revolution. But what you do is you count by 15s, but you skip your first 15 and your last 15 in each quadrant. So when you start at 0, you skip 15, then you go to 30, 45, 60, skip 75, and go to 90. So in the next quadrant, you'll skip the first 15, you'll do the next 3, and you'll skip the last 15 and go to 180. And you'll do the same thing in these two quadrants. So when you're doing your degrees, skip the first 15 and the last 15 in each quadrant, and that's the degrees that you use, okay? What we're fixing to do, we're going to fill out these tables and figure out some of these values. It says right here to memorize these values. That means you need to memorize your unit circle, okay? I put that on your haiku page, but I can't stress it enough. Memorize your unit circle. Take one quadrant at a time, okay? So what I do with my unit circle is I actually color code it, okay? So here's my first quadrant going from 0 degrees to 90 degrees. You need to memorize the degrees, their equivalent radians, okay? You know how to convert between degrees and radians, but you don't want to have to sit there and do that when you're taking a test. So you need to memorize the radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4. 60 degrees is pi over 3. And 90 degrees is pi over 2. I'm fixing to show you how we come up with these values right here, okay? But you need to memorize them, okay? Now, let's talk about 0 and 360 degrees. 0 and 360 degrees is found right here, okay? So the point on the circle is actually going to be, if you go from 0 here, this is a radius value. So your point is going to be 1 and 0. because it's on the x-axis, y has got to be 0. All right, so to find the sine, cosine, and tangent of 0 degrees and 360 degrees, look at that ordered pair, okay? Sine is always going to be your y value. So the sine of theta is actually equal to 0 because that's what your y value is, okay? The cosine is going to be your x value, which is 1. And then going from there, your tangent is your y over your x. So that's going to be 0 over 1, which is just 0. Okay? So the sine of 0 is 0. The cosine of 0 is 1. And then the tangent of 0 is 0. Okay? And then you can find your reciprocal functions if need be. Now, let's talk about 30 degrees and figuring out all this information. So, we know that to change 30 degrees to radians, we multiply by pi over 180 degrees, okay? 30 and 180 will cross cancel or reduce by 30. 30 into 30, that'll give you 1 pi. And 30 into 180 will go 6 times. So 30 degrees is pi over 6 radians. Okay, now how do we find sine, cosine, and tangent? How do we get that ordered pair or that point at the end? So let's go and look at the coordinate plane. Okay, so here's our x and our y. Now if I were to draw a 30-degree angle, okay, so it would look like this because it's going to go counterclockwise, a positive angle. If it's on the unit circle, you see how I've drawn the angle here? I'm just going to drop down a height so I can create my right angle. So if this is 30 and this is my right angle, I know that this has to be 60 degrees, doesn't it? Now, imagine your circle coming through, so that tells me that my radius or my hypotenuse here has got to equal 1. Now, in a 30, 60, 90 triangle, the side that's across from 90 degrees is 2x. So 2x equals 1. So that tells me that x is equal to 1/2. X is what's across from our 30-degree angle. Okay, now what's across from my 60-degree angle, that is going to be x square roots of 3, which will be 1/2 times the square root of 3, which 1 times the square root of 3 is the square root of 3 over 2. Okay, so across from 60 is the square root of 3 over 2. So that means my ordered pair, my x and my y, this is my x, it's the square root of 3 over 2, and this is my y, which is 1/2. Okay, so that's going to be my point on the terminal side, the square root of 3 over 2 and 1/2. So when we go over here, my point is the square root of 3 over 2 and 1/2. Okay, so that tells me that my sine is going to be my y value, which is 1/2. My cosine is going to be my x value, which is the square root of 3 over 2. And then my tangent is my y value, which is 1/2, over my x value, which is the square root of 3 over 2. Well, this is a complex fraction, a fraction within a fraction. So I'm going to copy, change, and flip. Now my 2's will cross cancel, and I get 1 over the square root of 3, which I am going to rationalize, okay? And that's going to give me the square root of 3 over 3. 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is just plain old 3, okay? So that gives me my radians, 30 degrees is pi over 6. My sine is my y value. My cosine is my x value. My tangent is y over x, which I had to copy, change, flip, and then rationalize the denominator. So that was a lot of work. And that gave me the square root of 3 over 2 and 1/2. Okay? Now, let's look at 45 degrees. So, I drew my 45-degree angle. This is my initial side. This is my terminal side. I'm looking for the point on the terminal side. Okay, my ordered pair, my x and my y. Now, since this is a 45-degree angle and a 90-degree angle, this will make this a 45-degree angle. So I know that these two sides are congruent. So x and y for my 45 degrees have got to be the same, okay? So I know that across from my 90-degree angle, in these particular problems, my hypotenuse is x square roots of 2. So x square roots of 2 in this problem equals 1. So let's solve for x, and once I solve for x, I'll know my two sides. So I have x is equal to 1 over the square root of 2, which we know is not going to happen. So let's rationalize this denominator. 1 times the square root of 2, and then the square root of 2 times the square root of 2 is 2. So that tells me each side is the square root of 2 over 2. Okay, so my x right here is the square root of 2 over 2, and my y is the square root of 2 over 2. Okay, all right. So now that we know what x and y are for 45 degrees, we're going to fill that in. Okay, now I know that 45 degrees times pi over 180 degrees. Okay, I can simplify this by cross-canceling 45 and 180. 45 into 45, 45 into 180, and I end up with pi over 4. Okay, so 45 degrees is equal to pi over 4 radians. My sine is the square root of 2 over 2. It's my y value. My cosine is the square root of 2 over 2. It's my x value. Tangent is the square root of 2 over 2 over the square root of 2 over 2, which is just 1. We know a number over itself is always equal to 1. Okay? Now let's look at our 60 degrees. So, same drill. I've drew my 60-degree angle. I'm looking for the point on the terminal side. This is my initial side. I dropped a height, and that made my right angle. Okay, so I know my radius is equal to 1. I know I haven't done a very good job of drawing these to scale, but y'all know me by now. Okay, so that'll be my 30-degree angle. So I've got, once again, 2x equals 1. So x is equal to a half. Okay, so that's going to be what's across from my 30-degree angle. So x is a half. Now to find what's across from my 60-degree angle, which in this case is going to be my y, I have to do x square roots of 3. Okay, so I know that x is a half times the square root of 3, and that's going to give me the square root of 3. 1 times the square root of 3 is the square root of 3 over 2. So my ordered pair is going to be x, which is a half, and y, which is the square root of 3 over 2. Okay? So x is equal to a half, y is the square root of 3 over 2. See how they're opposite of one another? Because this is a 30, 60, 90 triangle, and this is a 30, 60, 90 triangle. Okay? And then this is my 45, 45, 90. Now, let's go ahead and convert our radians. We've got 60 degrees times pi over 180. 60 into 60 and 60 into 180 will give me pi over 3. So 60 degrees and pi over 3 radians. Okay, now my sine is my y, square root of 3 over 2. My cosine is my x, 1/2. And then my tangent is going to be y, which is the square root of 3 over 2, over x, which is 1/2. So copy, and then change division to multiplication, and then flip. Your 2's will cross cancel, and you get the square root of 3 as your tangent. All right, now let's very quickly look through the 90, 180, and 270. Now 90 degrees, if you remember, is located up here. So its ordered pair will be 0 and 1. So I can just jot this down right here, 0 and 1. So 90 degrees times pi over 180 gives me pi over 2 radians. My sine is going to be my y, which is 1. My cosine is going to be my x, which is 0. My tangent is y over x, which is 1 over 0. This is a big no. We cannot have 0 in the denominator. So that tells me that my tangent is actually an undefined value. Now let's look at 180 degrees. 180 degrees is located right here. The ordered pair is going to be -1 and 0. Okay, so I have 180 degrees times pi over 180 degrees. Well, look at that. That's nice, isn't it? So 180 degrees is actually equal to pi. So let's find our values. Sine is our y, which is 0. Cosine is our x, which is -1. Tangent is y over x, or 0 over -1. Now this is okay. Okay, so our tangent is just going to be 0. Now looking at 270 degrees, 270 degrees is going to be located right here. So that means x is 0 and y is -1. Okay, so if we do 270 degrees times pi over 180, okay, we can cross cancel by 90. 90 will go into 270 3 times and into 180 2 times. And that's going to give me 3 pi over 2. Now sine is my x, which is, my y, which is -1. Cosine is my x, which is 0. Tangent is y over x, which is, again, that's a huge no. Can't have 0 in the denominator of a fraction. So once again, your tangent is undefined. Okay? So what we want to do now is we want to take these values and we want to transpose those onto the coordinate plane. Now I gave you one in this particular section, so let's go over here and look at it. Okay, so this is the one that we want to look at. All right, so let's fill in all the values that we've just come up with. Now for 0 and 360, we determined that it was 0 radians, okay, and that the ordered pair was 1 and 0. Okay, now for 30 degrees, that's going to be pi over 6. Okay, and then the ordered pair was the square root of 3 over 2 and 1/2. Now for 45 degrees, that's going to be pi over 4. And then we have the square root of 2 over 2 and the square root of 2 over 2. For 60 degrees, we have pi over 3. And that one's going to be 1/2 and the square root of 3 over 2. Okay, then we did our 90 degrees, which we determined was pi over 2. All right, and so our ordered pair for this one is 0 and 1. Then we did 180, which is just pi, okay, and 180 is going to be -1 and 0. Then we did 270 degrees, which is 3 pi over 2. Okay, and its ordered pair is 0 and -1. So 0 and 360, remember, are the same. So we went ahead and filled in everything that we got from our table that we just filled out. So how are we going to get these other values? Okay, so if you'll look right here, okay, with 60 degrees and 120 degrees, let me pull my unit circle over here. Okay, do you see how 60 degrees and 120 degrees have the same ordered pairs? Except x is negative. 45 and 135 have the same ordered pairs, except x is negative. 30 and 150 have the same ordered pairs, except x is negative. Okay? And then when you go down here, all right, when you go to 210, notice that 150 and 210 have the same ordered pairs, except x and y are negative. 135 and 225 match, but x and y are negative. 120 and 240 match, but they're both negative. Now compare these two. 240 and 300 are the same, except y is negative. 225 and 315 are the same, but y is negative. 210 and 330 are the same, but y is negative. Okay, so go ahead and fill all those in. Now, why do we have a change of sign? It comes from the quadrants, okay? So if you look right here, this 30, 45, and 60 are in the first quadrant where X is positive and Y is positive. But when you get over here to the second quadrant, X is negative and Y is positive. So 60 and 120 have the same values, 1/2 and the square root of 3 over 2. If you're in the second quadrant, X has to be negative. Okay, if 45 and 350 match, the square root of 2 over 2 and the square root of 2 over 2, you're in the second quadrant, so X has to be negative. With 150 and 30, you have the square root of 3 over 2 and 1/2, but X has to be negative. So if 150 and 210 have the same values, okay, so this will be the square root of 3 over 2 and 1/2. But in the third quadrant, X and Y both have to be negative. So square root of 2 over 2 and square root of 2, X and Y both have to be negative. Okay, 240 and 120 are going to match, so it'll be 1/2 and the square root of 3 over 2, but X and Y both have to be negative. And then 240 and 300 are going to match, so 1/2 and the square root of 3 over 2, but in the fourth quadrant, X is positive and Y is negative. So this one will be square root of 2 over 2 and square root of 2 over 2. So X is positive and Y is negative. Right here you'll have the square root of 3 over 2 and 1/2, but X is positive and Y is negative. And so we have filled out the unit circle, okay? We've already had our degrees, but we filled in the radians that we had. We can fill in the rest of these by simply converting them over. But this one will be 2 pi over 3, 3 pi over 4, 5 pi over 6. This one right here will be 7 pi over 6, 5 pi over 4, and 4 pi over 3. Then we already have this one. With 300 degrees, that's 5 pi over 3. 315 degrees is 7 pi over 4. And then, of course, 330 is 11 pi over 6, okay? And this is 0 radians. You need to memorize all of this. Memorize your degrees, memorize your radians, and memorize these ordered pairs, okay? Because that way, if you already know what they are, then when I ask you, what's the sine of 60 degrees? Oh, it's the square root of 3 over 2. What's the cosine of 225 degrees? Oh, it's the negative square root of 2 over 2. What's the cosine of 300 degrees? Oh, that's 1/2. What's the sine of 150? It's 1/2, okay? What's the sine of 330 degrees? Negative 1/2, okay? You don't even have to compute anything. You already know what it is, okay? So that's your unit circle. Now down here, it's asking you, what are your trig values? Sine is y, cosine is x, tangent is y over x. Now this is with the unit circle because we know it's y over the radius, which is 1, x over the radius, which is 1. So if you look at quadrant 1, you're looking at sine. All of your sine values are what? Every single one of them in quadrant 1, positive. All of your cosine values, which are your x's, every one of them, what? Positive. And if you have y over x, positive over positive is a positive. Now look at quadrant 2. Now, your sine values, which are going to be your y's, here, here, and here, all of them positive. Your cosine values, which are going to be your x's, all of those are what? Negative. So if tangent is y over x, a positive over a negative will give you a negative tangent in quadrant 2. So positive sine, negative cosine, negative tangent. Quadrant 3, If you look at your sine, which is your y, all of those are negative. If you look at your cosine, which is all of your, which is all of your x's, all of those are negative. So a negative over a negative gives you a positive. So in quadrant 3, you have negative y over negative x, which is a positive tangent. Now quadrant 4, your sine, which is your y values, all of those are negative. Okay, and then if you look at your cosine values, which are your x's, all of those are positive. So a positive or negative over a positive is a negative. And there we go. We have figured every one of them out and where they came from. Now on the unit circle that I gave you, okay, you'll see that in quadrant 1, everything is positive. Okay, sine, cosine, tangent, secant, cosecant, cotangent. Okay, when you go over here, the sine is the only thing that's positive in quadrant 2. So its reciprocal function has got to be positive too. So that's why you got sine and cosecant. In quadrant 3, the only thing positive is the tangent. So its reciprocal function has to be positive as well. And then in quadrant 4, your cosine is the only thing that's positive. So its reciprocal function has to be positive. So cosine and secant.